Welcome to Numbers Simplified. In this channel, we seek to simplify and solve numerical problems. Today, we'll be looking at the introduction to differentiation applications. Take note, this is part 9 of the differentiation series. So make sure to subscribe, like, and share so that you don't miss out on any of our future uploads. And also, I encourage you to check out our playlists, integration, polynomial, quadratics, among others. Now, let's look at example 1. So we are going to apply the differentiation concept in these questions. The concepts we covered from differentiation part 1 to part 8. So make sure you go over the videos so that you appreciate each and every step. Now, we have example 1. A solid cylinder has a radius of r centimeters and height h centimeters. The volume of this cylinder is 432 pi cubic centimeters, and the surface area is a square centimeters. A. Express h in terms of r. B. Show that a is equal to 2 pi r squared plus 864 pi over r. Let's start with the first question, part A. So the solution. We start by constructing the diagram so that we have a picture of what the question is asking of us. So we see the cylinder with the radius r and the height h. Then the next thing that we're given is the volume. And we know the volume of a cylinder is given by pi r squared h, and then we equate that to 432 pi. With that, we are going to solve for h by dividing throughout by pi r squared so that we have 432 pi over pi r squared. Now, this would be closer to the final answer because we see that the pi's will cancel out so that we have our h as 432 over r squared centimeters. The first question is done. Let's move on to part B. So for part B, we know that the surface area of a cylinder is given by 2 pi r squared plus 2 pi r h. Then with that, we are going to substitute for the h that we obtained in part A of 432 over r squared. And with that, we can actually simplify our answer so that we get 2 pi r squared plus 864 pi over r. Now, that answers part B of the question. Let's jump into part C. With part C, the question says, find the value of r for which there is a stationary value of a. Now, we know what a is. A was obtained from part B, the surface area. Now, with that, we are going to find the first derivative of a with respect to r. So, the r becomes 4 pi r minus 846 pi r to the power minus 2. Then we equate that to 0. Now that is the first derivative with respect to r. We equate that to 0 because that's where we are going to get stationary points. Now with that, we move the negative term to the right hand side. Then afterwards, we multiply throughout by r squared so that we have 4r cubed is equals to 846. And then divide by, of course, by pi, we get to that. Then simplifying further, we are going to get the r cubed is equals to 216. Implying that if we introduce the cube root on both sides, we end up having r is equals to 6 centimeters. So now it implies that this is where we get the stationary point, where r is equals to 6. Now let's look at part D. Determine the magnitude and the nature of this stationary point. So for the magnitude of A, we have where this happens, where there is a stationary point, and there is only one stationary point because we got one value of R. We substitute into the equation, or rather the formula of the surface area A, where we have R, we substitute with 6. In that case, we are going to get 216 pi. So that will be the magnitude of the stationary point. Now, in order to just verify and to see what the nature of the stationary point is, we will need to take the second derivative. That is to say, from the first derivative, we differentiate again with respect to R, we are going to get 4 pi plus 1728 pi R to the power minus 3. Now we know what R is. R is a 6, so we just substitute the R with a 6. We simplify further, and we get 4 pi plus 8 pi, which gives us a 12 pi. This is greater than 0, so implying that the stationary point 216 pi is a minimum point. So that answers the first example. Let's take a look at example 2. So we have this question over here. The sum of two real numbers, x and y, is equals to 9. So for the first part, A, express y in terms of x. So that should be easier. The solution. So we know that x plus y, the two real numbers, would give us a 9. So in order to express y in terms of x, we are going to make y the subject of the formula. Then moving the x to the other side of the equal sign, we are going to get y is equals to 9 minus x. So now moving on to part B, item 1. Given that p is equal to x squared y, write down an expression for p in terms of x. Now, we know that p is that. Also knowing what y is, we are going to substitute for y so that we get p is equal to x squared times 9 minus x that we obtained in part A. Now, of course, expanding the bracket, we get p to be 9x squared minus x cubed. That will be the final answer. Now, item 2 of B says find the maximum value of p. So to find the maximum value of p, we need to find the first derivative of p with respect to x. And that becomes 18x minus 3x squared. Then we equate that to 0 because we are trying to find all the stationary points that we would then determine if they are maximum or minimum. Now, with that, we can actually factorize so that we have 3x times x minus, 6 minus x is equal to 0. Then, of course, setting each term to 0, we are going to get 3x is equals to 0, or 6 minus x is equals to 0. Then solving for x, we are going to get x is equals to 0, or x is equals to 6. So the stationary x coordinate are x is equals to 0 and x is equals to 6. Now we move on to find the second derivative of p with respect to x, which would be 18 minus 6x. And of course, we are going to substitute for the x values so that we determine the nature of the stationary points that we got. So at x is equals to 0, substituting into p prime prime of 0, we are going to get 18 minus 6 times 0, and that would give us a positive 18. And this is greater than 0, implying that the stationary x-coordinate is a minimum. So this x-coordinate of 0 would give us a minimum point. Now we do the same thing for x is equals to 6. So now we are going to substitute into p prime prime of 6 so that we get 18 minus 6 times 6. And that is going to give us a minus 18, which is less than 0. With that, then, it means the stationary x-coordinate would result in a maximum turning point. So the maximum point then becomes, we need to find the p of 6, because we know that there is the x-coordinate that results in a maximum. So the x-coordinate is a 6. So we are going to find the p of 6, so that we have 9 times 6 squared minus 6 cubed. Simplifying that one would give us a p of 6, which is 108. Therefore, now we have the x-coordinate and the y-coordinate. Then the maximum point is 608. Moving on to part C, item 1. So we're given that the q of x is 3x squared plus 2y squared, and we are asked to find the expression of q in terms of x. Now, recall from the y that we obtained in the first part of the question, we are going to use the same y since it's the same question. Therefore, where we have y, we substitute with the 9 minus x so that we get 3x squared plus 2 times 9 minus x squared. And of course, expanding the squared bracket, we are going to get that. And simplifying further, we get 162 minus 36x plus 5x squared. That will be our q of x. Now, we move on to determine the minimum value of q. So in order for us to do that, we are going to find the first derivative of q with respect to x, so that we get a minus 36 plus 10x is equals to 0. Because we are trying to find the stationary point, we equate the first derivative to 0. Afterwards, we solve for x so that we have x is equals to 36 over 10, and simplifying that further, we are going to get x is equals to 18 over 5. Now, checking if this one is a minimum point, because we know that we are meant to find the minimum value of q. So this is the only x-coordinate that we have of 18 over 5. So we're going to differentiate for the second time. But of course, it wasn't necessary for us to do so, but just to be sure. Now we find the second derivative of q with respect to x. That would give us a positive 10. And this implies that we are going to have a second derivative, which is a positive, implying that this is a minimum point. Anyway, so we are going to find what the minimum point is in terms of the q value. So the q of x, we know it from part C, item 1, to be 162 minus 36x plus 5x squared. Now substituting for the x that we obtained in part 1 into the q, so that we have a q of 18 over 5. Wherever we have x, we substitute with a 18 over 5. Now simplifying further, we are going to get that bit. And going on to simplify, we end up having the q of 18 over 5 becoming a positive 97 and 1 over 5. This is the minimum value for q. So with that, we can actually express it as a decimal, 97.2. Right, if you have made it thus far, I say congratulations. I'll leave you with the following task. Make sure to send in your questions so that we work them out together and help each other. Remember to like, share, and subscribe so that you don't miss out on any of our future uploads. Thank you once again for watching Numbers Simplified. And remember, God loves you.